We are out here at our Balance of Rock project in North Scottsdale. This is out near Troon. This is an incredible build with PHX architecture, and you can see the reason why. This is an ICF home, so this is Fox blocks, and you can see all the structural steel behind me. We're going to be speaking about the structural steel today. So really, we want to break down what goes into structural steel from a subcontractor point of view, how this is all priced out, what goes into the coordination, trip charges, and everything behind the scenes that we're coordinating with our subcontractor as well as our vendor with the structural steel. So first point, we have our plan set and pre-construction. So we're working with the architectural team. Again, because this is ICF, solid concrete walls with styrofoam, a lot of the weight's being carried through the structural steel, especially because this is a modern build, because this is modern architecture, a modern design. We have these large openings. Again, you can see here, this is gonna be the back patio area, the master suite behind me, and I'm actually standing, we have the kitchen and great room area and the entry. So for this reason, because we have these long spans, you need structural steel for deflection. With the wood glulam beam, the size of those glulam beams, deflection, there can be challenges. That's why typically when we have these large spans, we're always gonna go structural steel. Now, what's really important with our subcontractors is you think what goes into the cost and price of installing structural steel in a home. There's really two categories, like most, but again, you have weight, so tonnage in pounds, which is the weight of the steel. So that's a big factor, the material. How much it weighs, that's going to be typically your cost, and that can fluctuate depending on the market, just like lumber can fluctuate. Second thing is labor, but here's how it impacts you. On some of our jobs, we may have large spans and minimal pieces. So you may have 6 or 7 pieces of structural steel that weigh a lot, and so the pendulum's going to swing. You're going to be paying a lot more for material than you are for labor. Or it could go the other way, that you have 60 pieces of steel, and in that case, most likely you're going to be paying a lot more in labor than the actual material itself. The reason being is to install and weld and fabricate 60 pieces of steel and bring those out and set those. There's a lot of coordination and labor that goes behind that, especially the welding and setting in place. And so those are really the two factors. Now, something you really have to consider is access. Most of our project job sites, and we're gonna do another video on access on this and why this job access is our most complicated access job to this point, which is kind of surprising, being that we have some really challenging hillside projects, but we'll come back to that. As far as this is concerned, most of the time, slab is poured and then we come set the steel. You can see here we have our anchor bolts. So in most cases, you're gonna pour the slab, we have it blocked out here, we have our template here, anchor bolts, and the steel plate our base plate that's typically 3/4 of an inch to 2.5 inches, depending on the engineering, will be installed here, and we go high. Because of access, we had no room to do that on this project. That's why all of the structural steel installed here was actually done before we actually poured concrete and we poured the slab. And so after we get the bid worked out, we figure out the tonnage, the weight, we figure out the labor, and we have our price set. The next step, and this is way before we start construction, our structural steel company will go do shop drawings. So they essentially do 3D modeling of the structural steel layout, and we know every piece that's going to go into that build. And so now they're breaking that down. So they're going to take their interpretation of the plans, because the reality is, as opposed to commercial construction that's very laid out, and residential construction, a lot of times the details are lacking when it comes to structural steel. They're going to rely on the vendor for that. So we're going to put together 3D modeling, and then we're going to send that to the EOR, which is the engineer record. And they're going to sign off and make sure everything's cohesive with the actual design and intent of the build, which we did in this case. So of course, the engineer record's going to sign off and stamp, our 3D modeling of the structural steel. And then we're coordinating that with the steel subcontractor and our vendors, especially framing, because we still will have beams and columns, and of course, over framing, interior wood framing, and then we have the ICF walls. So we have to coordinate between all those vendors to make sure that everything's going to line up as we come out into the field. Now, once that's done, once it's signed off, we understand, our pool plan schedule. We understand, the sequencing of who's going to be coming out, when, how we're going to install this. The next item, there's two things. You have anchor bolts and embeds, and I'll explain the difference there. So anchor bolts are what you see here. It's pretty common that, our steel company, this is the first item they have to deliver. These are anchor bolts. Now, you can see here that we have like an 1/8 plate of steel, and this is really just a template. This gets thrown out. But essentially, we give these to our concrete guy, so our concrete company. They're going to take that 3D modeling and those plans, and we're going to deliver these anchor bolts. And on this project, you probably had about 24 of these on this project. And the reason we have this quarter or this 1/8 of an inch plate is really to hold these in place. So we're going to keep the exact dimensions. It makes it easier than trying to set 4 anchor bolts. And what happens is the minute footings are poured, so that's when we're going to come in. So going back to the 3D modeling with our structural steel company, we really want to understand top of footing. We have to understand that top of footing from a survey. Then we can design the anchor bolts, because as we come in and we're pouring stem walls in the slab, we're going to know exactly where these anchor bolts have to be. So our concrete company, we're going to deliver these. They're going to come out and we're going to check all of it. But essentially around the house where the structural steel posts are going to be, these are set into the concrete. And then now as these are set in, and the concrete cures, those are going to be anchored in place. Now we come back and of course that plate is removed. That's just a template, that 8 inch. So that 8 inch, we're not going to use again. That gets discarded or recycled for the next project we do. And then the actual plate of the column, because as you set this column, as I mentioned, that base plate is typically 3/4 to 2.5 inches thick. And then we tighten that down with the nuts, and then we're gonna pour the concrete over top. And typically this happens under slab. We don't want to see the plate. We don't, the bolts, anything is typically be under slab. We pour the top. And then that way have this nice flush transition as we see here, coming right out of the concrete. Makes it easier for us to do the finish of the house. So after that's done, normally what would happen is we have our anchor bolts in and an embed. That's different. So an embed on occasion, and I don't have a sample here, but as you think about this, you could have, imagine here we have a plate. So you'd have here a plate that's flush, the metal plate, and then you're welding directly to that plate. And that's called an embed when it's flush. And these are the anchor bolts. It could happen ICF. We're gonna have some where the embeds are in the ICF, so that as you're putting your beams up, it welds directly to those embed plates. Now, after the slab is poured, the structural steel company will come back. We have our anchor bolts in place, our template. That gets pulled, we set our steel, we fabricate, we install. And it's typically, 2-3 days that we're in and out with all the structural steel. This case is a little bit different at Balancing Rock. We had to come in. We actually had this right when footings were done. Footings are done, and we came and installed all the structural steel all around this way before underground plumbing, before underground electrical, and before slab. So we had steel flying through the air and installed before our concrete trucks came out and we're forming the stem walls and putting the ICF. Again, understand how important it is to know your schedule and access. This is definitely a unique one where we actually had to go a different sequencing order as opposed to every other project we've ever done with structural steel. The reason being for access. So make sure you're having those pool plan meetings. And again, this is a breakdown of how we do our steel.